All right, thank you everyone for your forbearance. It's always a great sign when the president and professor of geology have to get more chairs. So thank you everyone for bearing with us. Hope you had a great time with the poster session back there. I think most of them are gone, but a few are still up there. So, if you're of a mind afterwards, perambulate and see our posters. And so my name is Ray Rice. I'm president here at the University of Maine at Presque Isle. Particularly happy to have you all on this at least somewhat spring-like evening, and welcoming you tonight for a very special keynote address as part of our Libra Distinguished Lecture Series and University Day activities. We always kick them off with a lecture and a poster session the evening before, followed by tomorrow with a day full of University Day activities. We're very pleased to host Owen McCarthy, co-founder of MEDRhythms and leader in neurotherapeutics for this evening's presentation. This is a hybrid talk, so welcome as well to our audience members joining us virtually through our YouTube live stream. Our series has given us the opportunity to present a wide range of speakers, from astronauts and journalists to scholars and adventurers, for our campus and community since 1999. Over the years, we've welcomed more than 100 speakers as part of this series. Our University Day activities began early this evening with a poster presentation I just mentioned, and continue tomorrow with a score of student presentations on topics ranging from exploring how movement is expressed in video games. I think that's Ryan, right? Is Ryan here? There's Ryan. My movement is like really poor in video games these days, but is expressed in video games using code to the impact of social isolation on older adults. The theme of this year's University Day is in fact Bold Frontiers, the intersection of creativity and innovation. And that is just a perfect topic for Owen McCarthy to speak to that tonight. To help set the stage, I'd like to turn the time over to Barb Blackstone, UMPI's Associate Professor of Exercise Science and Libra DLS Committee member, to provide an official introduction. Once again, welcome everybody.
Welcome everyone. Raised in Patton, McCarthy grew up watching his father, a third-generation logger, leave for work at 2 a.m. and still make time for his family. His mother, a second-generation lunch lady, taught him the power of community. Their examples shaped his belief that leadership isn't about titles, it's about showing up, working hard, and helping others succeed. As valedictorian of Katahdin High School, he learned firsthand from his teachers that education can open doors. At the University of Maine, he studied engineering as a pulp and paper scholar. He was elected student body president and became the first of his family to graduate from college. Later, he earned an MBA from Harvard Business School, where he learned and practiced the tools to build and lead organizations. He co-founded MEDRhythms, a company pioneering FDA-approved technology to help people regain mobility after a stroke, multiple sclerosis, or Parkinson's disease. Originally launched in Boston, he moved the business to Maine, proving that world-class innovation can thrive here. Under his leadership, MEDRhythms has raised over $60 million in capital and recognized as an FDA breakthrough technology, and created high-paying jobs, all while advancing cutting-edge technology that serves people nationwide. In his service to the community, he is a trustee for the University of Maine system, lifting up young people in small communities like Patton through the World's Fund and the Digital Therapeutic Alliance, where he advocates new approaches in healthcare. In recognition of his impact, he was named a Presidential Leadership Scholar. McCarthy and his wife, Holly, and their 2 sons live in Gorham and spend their summers on Porter Lake. In his free time, he enjoys playing basketball, watching Maine high school basketball, a hobby that deepens his connection to the communities across the state and fuels his commitment to Maine, ensuring that it remains a place where next generations can thrive. Welcome to Harnessing Technology, Music, Neuroscience to Transform Healthcare, the MEDRhythms Story.
No problem. Good to see everyone tonight. Mike, yeah, good to see you all tonight. Before I begin, just want to say how grateful I am that everyone came tonight. I see people from many walks of my life, including from Patton, from Katahdin High School crew over here, including from when I first started working, which wasn't in the bio, in chemical sales. Jeff over here works at McCain Foods. I worked with Jeff and Kathy, who I spent some time on the UMaine Board of Visitors with. So it's really good to see some friendly faces in the crowd. I think the University of Maine Presque Isle actually was important in my journey. When I was an eighth grader, maybe a seventh grader, seventh or eighth grader, I was part of the Gear Up program. And my first experience with a university campus was spending a week here in the dorms, in the residence halls, having some fun. I think we learned something while we were here too. And so, thank you for what you continue to do. I must admit, when I went to the University of Maine at first, I used to tell everyone that, I'm from the county, right? And so I got to a fraternity meeting, and one of my fraternity brothers, who was from Caribou, was like, well, first of all, Owen, he got up in front of everyone. They made this whole presentation. First of all, Patton is not in the county. It's in northern Penobscot County. And second of all, is Southern Aroostook County really the county? And so I'm glad you let me come back here tonight. So my plan for the presentation is I'm going to start by telling you sort of the story of how and why we started MEDRhythms. And then I'm going to go into the science of why music can help people walk better and what we saw. And then I'm going to go into the products that we built and some of the clinical data that we've had. So that's the plan for tonight. There'll be plenty of time for questions for people in the audience, and I would love to answer them and welcome them. So MEDRhythms. I can't start the journey of MEDRhythms without mentioning my good friend, Brian Harris, who's my co-founder. And Brian he's a West Enfield native, and he's trained as a neurologic music therapist, which is a field that has about 2,000 people trained like it in the world. It's very niche. And it actually was Brian's life's mission. And I've sort of like jumped aboard to figure out how to use music to help people recover ever since I've known him at 18 years old. So, which is a remarkable thing if someone has that sort of mission at that point in time. I was roommates with him in Boston when he was starting his work as a clinician. He started at Spaulding Rehab, which is, if you don't know, is one of the top 4 or 5 rehab hospitals in the country. It's affiliated with Harvard Medical School. And he was one of like 3 programs in the country that was doing this. And he kept coming to me, and I'm going to show you the video later tonight with videos of people that were recovering faster and more effectively with how you can use rhythm and music to help them walk better. And said, Owen, like there's got to be a way to take this out of Spaulding when people leave and reach more people. And so I was wrapping up business school at the time. And instead of looking for a job, I decided, hey, Brian, let's figure out how to answer this question together of how do we take the science you're doing as one person at Spaulding Rehab and reach more people, and thus MEDRhythms was born. Early days, though, we said, like, look, why don't we train more Brians? So that's not part of the story you'll see later, but we said that's all we need to know how to do. Like, there's 2,000, there's people that need to be reached in their homes, now they're hospitals. If you train more people and get them up to speed and get them out there, maybe we'll help out. And so for the first 2 years of the company, we did that. We were, think like a therapy service practice. We had a contract with Spaulding. We had a contract for like outpatient rehab and did some in-home care. And it was going well. But we looked out there and said, there's 3.5 million people that have walking deficits after a stroke, and there's 1 million plus with Parkinson's disease, and there's a lot of people that have had multiple sclerosis. And the way we're doing it is going to scale in about 100 years to reach them. And so we've got to, like, I'm probably not going to live that long. And so like, we've got to try to do it a different way. And so we said, well, Brian, what he really was doing is he's watching someone walk, analyzing their gait, which we'll get into a little bit, and changing the music and rhythm in real time in this closed feedback loop. And we said, well, we think we can take Brian's brain and turn it into an algorithm that takes input from sensors that measures the walking in real time, analyzes that, and change the music back towards someone, all in this kind of closed loop fashion. And we think we can take it instead of having them have to come, which it can be used in rehab facilities, but like, instead of having them have to come to a rehab facility, let's ship it out and be used in their homes if they can do it on their own. And so thus that part of the journey was started. Where from there I'm so glad we didn't know what we were doing at that point, because if you think about building, and this is if anyone ever wants to be an entrepreneur, some of your best moments are when you're naive, that you're willing to try something and get to the next hill, because trying to bring something to market in healthcare, like there's 7 different lawyers we had to figure out how to work with. Like we had to go through clinical trials. We ran 7 different clinical trials. We had to figure out how to design clinical trial. Obviously, we hire good help along the way, but design clinical trials. We had to build technology. You know, I have an engineering degree, but I'm not a software engineer, so we had to figure out how to do that. And then we had to figure out how to navigate the FDA, which is a whole nother set of regulations and meetings, and there's a certain amount of circumstance. Then you get it on the market, and then you're like, oh yeah, someone needs to pay for it. And so you need to figure out how to navigate insurance. And today, I'll get into the story in a minute, we've gotten through all those hoops where we've gotten through successful clinical trials, through the FDA, and got ourselves a Medicare code for the product, which is now live for people that have chronic stroke walking deficits or people that live with Parkinson's disease. So we're excited about that. So let me get to, I covered many of these things. So I mentioned the video that Brian shared with me, and this is really our why. We always come back to at the company, you know, how do we make decisions? Well, it's like, how do we take what we're doing and reach more people, like we saw with George that I'm about to show you. George, as backstory, this is a stroke survivor. He had a stroke, and I think it might say it on the video, about 3 weeks prior to this being taken. He had some rehab, but not a lot of it. And this, I'm going to show you a result that we saw in one session at the rehab hospital with Brian as a live music therapist. And let me see if I can figure out the technology. Okay. Good. So far, so good. Nope. Pause, please. There we go. I have to hit escape. Building suspense. I need to share the whole screen instead of part of the screen. Me too. Back to- Up there. Back there. Okay, we got it. Okay. George, 3 weeks, had a stroke prior to this. Now it's fully gone. Okay. This is George. He'll. This is prior to doing any therapy with us.
Yeah, almost here, you know, without a pain.
And you often see this in a stroke. Someone may have an asymmetric gait. They take a long step and a short step. But we're going to go through a quick progression, but like he's trying to sync to the rhythm, and George can do that subconsciously. I'll explain why in a second. We take the pain away and we speed it up. And this is one session. Take it away because it's no good if Brian has to follow you around with the car. And this is walking afterwards. So he started at 65 ppm with a cane, beats the minute with a cane, and went to 120 afterwards.
When I started drinking warm water to help me lose weight.
That's not me. All right, so when we saw that, and when Brian kept bringing that type of video to me, it was real that we had to make sure that we got it to as many people as possible. So you might think, well, that seems like magic. Like, how did that work? And so now we're going to go through the science. So most of the people think about music through like a social science lens, like how it makes you feel, or like mental health, et cetera. In the last 20 years, people have done a lot of studying on what actually happens in the brain when you use different parts of music in a targeted manner. That's the neuroscience lens. There's three things that we will get to everyone. There's three principles here that's really going on in the brain that it's being taken advantage of. One is what we call global activation. Number two is neuroplasticity, which generally happens in our brains. And three is auditory motor entrainment. And so global activation, when you hear a music in your background and you look at it under MRI, it lights up almost everywhere in the brain. If you were to just look at walking generally under MRI, it's very localized. Like, it might be a spot where you like think about walking and a spot where movement happens. It doesn't light up everywhere. And so this global activation happens, that it's such a rich stimuli that it really lights up a lot of the brain. And so why that's important is, think of it almost like trying to build new roads in the brain for how you access different parts of things. Like if it lights up and there's a bunch of different nodes, you now take advantage of a different route to get to that ability. And so because of that, that's why you see someone like George reacting to having the rhythmic stimuli and being able to do things that he couldn't do otherwise. It's because it's accessing a different pathway to access movement in the brain. And that actually also applies, like if you see, there's a lot of research out there on like music and memory. There's a documentary called Alive Inside, which is another part of the reason why when you listen to music from like something that's salient to you that you understand, it starts to pull different memories in and use different parts of the brain than if you were to just like sit there. So it's a really powerful stimuli, but it's no good if you don't have neuroplasticity, right? Like which neuroplasticity is the ability of the brain to be plastic or to regrow like those pathways. And so this is something that we see in a lot of things. We use it every day. Often in the past, it was believed that neuroplasticity sort of slowed down and stopped as we got older, or after you have a stroke, they used to say like 1 year out, you can't recover anymore. It does slow, but it still exists out there and can be tapped into and take advantage of, which is the ability of the brain to relearn new things. And then finally, the last piece is, in addition to the global activation, the neuroplasticity, what we call auditory motor entrainment. And so auditory motor entrainment is specifically, if you hear a strong rhythmic cue in your background, like it activates your auditory system and your motor system simultaneously and subconsciously. You don't know that it's happening. Thus why, actually, if you were to run an experiment where you took a song, played it in the park, had everyone walk by and had it roughly around within 20% of what someone's walking cadence, everyone will start to sing to it and they don't even know they're doing it. It's sort of like this. And so because of that, you can use this fundamental as part of the ability to like change how someone's moving. Like you can speed them up, you can slow them down, you can do it without having to tell them to do it, which we found it was really compelling. And here's another video, but it's in here. And in children, like one of the things, the research that showed that like this was a thing was this is a little child and he can entrain to a rhythm even without instruction. So this is a fun video to show.
Yeah, to bed.
So that, I mean, that's obviously not therapy, but it sort of uses this principle of like the entrainment can happen without instruction, and then we take advantage of it for the products that we use, that we build. And so then the question was, as I've said before, why doesn't everyone have access to it? And now it became a problem of like delivery and healthcare system. And so that's what we did. We built the Intandem. And so the Intandem is an FDA-approved prescription product that helps people recover their walking, specifically if they've had chronic stroke walking deficits. So 6 months out post-stroke. It is intended to be used in home, with in their community, 3 times a week for 30-minute sessions. It's recommended in 2-month use durations. And we actually ship it as a kit, right? You think it's a software product, but we send 2 foot-worn sensors, a handheld device, which is a fancy word for a phone, and a set of headphones, all fully synced, because we found if we send someone an app to download and send them sensors, it failed like 95% of the time, like getting set up. So we basically made it a start button, all fully synced, easy to use, out of the box, which was really important. And so how does a session work? Like, what does it look like if you're using the product? Well, first, we start with collecting baseline gait data. So you put the sensors on each foot. I'm going to try not to walk off the stage. And you start walking, and we have 40 data points for every step that's measured. So we know everything from how high they pick the foot up, to how the swing was out, how long this foot stride was versus this stride. We know all that's happened in real time, and we use that to calibrate how we start the session. And then after we do the calibration, we bring in music, but it's not just any music. We've screened songs to figure out how it has the right properties for this intervention. We have added things to it, and we almost like a healthcare DJ, right? We kind of change it in real time to deliver it. And so we start at their baseline. So we always start where they are, because it's supposed to be individualized, challenging, and progressive. We start at their baseline. We then, in real time, are getting gait data back, which informs decisions with the algorithm makes. So the algorithm is saying, like, are they symmetrical? Are they variable? Are they walking to the beat? Like, should we speed them up? Should we slow them down? And that's happening every second. That's going on in the background. And then from there, we adjust based on that entrainment based on the value of if they've synced to the music or if their gait quality, we'll make changes to what happens. And then finally, we'll do that continuously throughout a whole session. We also get, which is fun for anyone who likes to play with data, we get all this data back every session. So we know everything that's happened with every one of our patients that we've ever had, basically, that comes back to us, which we think of as a really good way to like improve the product and do R&D and to do other things like that. So.
Hi.
All right, so here is our intro video of the Intandem. This, I just want to say, Chrissy, you're going to see in the video, was one of our longstanding product testers. She came into our office probably like weekly for like a couple of months, and would give us feedback on the algorithm, on the design. She took it home under a research protocol, and her husband Bill would walk along their road and would call us and say, like, got to change this, or the music's bad, or whatever. Right? And so Chrissy's a rock star. And so we had her do this video for us.
Hi, I'm Chrissy Bellows, and I had my stroke about 6 years ago now. 6 months before I had my strokes, I had retired from being an assistant teacher at a Montessori school, and stroke got in my way. It was a pretty severe stroke as far as what I've been told. Therapy started with people coming to the house, and I was left with nothing except the support group. And that's where MEDRhythms came in. The way I would say it is just walking to music, to rhythm, to a little bit at a time. They increase the speed that you were walking to. I really feel that it's really helped me. And my physiatrist, he was so impressed at how much I had improved that he said, come back and see me in a month. We've been with MEDRhythms ever since then. The music started and it felt so great. I started working.
I'm not willing to prove myself. I'm not feeling that good myself.
It's not only my life, it's Phil's life too, because as a result of it, I have come such a long way that there's no way he would have left me at home alone anytime. Now he does. And it's all thanks to MEDRhythms. Don't give up on us.
So we often bring in the Chrissies or like other examples of the world to come talk to the team because everyone's working really hard at MEDRhythms, and it's really important to let them all know like why we do this and how we do this. We get countless stories of people and what it means to them to walk better. Just the other day, and this is an everyday thing for most of us, but this guy called us and said, look, like I had a stroke like 5 years ago. And every Friday, I go to the Chinese restaurant. I get out of my car, I take my cane, and I walk in, and I get the thing, and it's hard to get the door open, and all these things. Started using the product, and a couple months in, for the first time ever, I walked in without the cane and got the Chinese food and came out and got back in the car. And for him, that was super meaningful. And for everyone, it's different, like why walking matters. But like it's important to us as we think about our team that they see these stories and they get to, they might be writing software, they might be doing quality and regulatory, they might be screening music, but to keep that top of mind is really important to us. So music, we actually, speaking of being naive getting into this, what we do with the music requires us to go get licenses from the record labels, which, if you don't know, there's 3 major record labels that own 90% of the world's music or something. So there's not a lot to choose from out there. And Universal Music Group, who is a partner of ours, they were an investor in the company, actually own 50% of the world's music. That's what they say. I don't know how they sum it all up, but that's 50% of the world's music, including for our population, like people that have had a stroke or living with Parkinson's disease. They own Motown Records. So that's a big, very popular one. They also own Taylor Swift. So Taylor could make an appearance in the product. So what we see is we look at it through 2 lenses. One is the sort of the makeup of the music being what the rhythm is, like very scientific, right? Like what the rhythm is, what the frequencies are, what this is. We know what makes a difference on people's lives there, and we can screen a song for that. But the reason why we wanted to get universal quality music was there's some research out there that suggests if you use music that people like, they will do it. So that's good. That's not a shock. But B, they actually get better outcomes, which was something that was not obvious to us when we first went into this work. So we've done multiple clinical trials. This was our feasibility study. I'm not going to go fully into it. maybe I will. Like, this was sort of this was the does it work test, right? Like the first time we tried it in a controlled setting with the product and said, can we get an outcome for patients autonomously without having a clinician in the loop? It was small. It was 11 subjects. It was not that long of a training session, but we did see increases in walking speed, which is important because if someone walks faster, it's like riding a bike. If you walk too slow, you're actually more unbalanced. Like there's like a resonance frequency that makes sense. So you walk faster, it's more in balance. And actually every 0.1, which this was right on the line, the next study was better, meter per second increase in walking speed lowers fall risk by 10%. And so, which is obviously really important because falls, cost money and like high mortality rates on the other side of them, et cetera. We also saw people's quality of walking, which we call symmetry. You noticed how George had the long step, short step, right? The symmetry got better throughout. And then the other thing that we've seen, but we didn't study in subsequent trials yet, but more economical walking. If you would have seen the study, they were wearing like a mask, like the guy from Batman, Bane or whatever, right? But it measures like O2 content. And we saw pre, without any intervention, and post afterwards, people had actually become more efficient at walking, which was a surprise to us. Like they burned less energy, less oxygen to walk. So it's like a miles per gallon type of thing. So that was interesting to us. And then we did this pivotal trial, which, by the way, we started it like 3 months before COVID hit, and then had like existential moment where we don't know if this is ever going to start back up, and the trial was shut down and almost ran out of money. But we got through all of that. And here's the trial. This was a 8-site randomized control trial, which means like had the intervention, compare it to something like standard of care, like someone normally would do in this. We did 5 weeks, 3 times per week intervention, looked the beginning, and then 3 days after the last session is sort of how we collected the data, because we want to make sure that we have the neuroplasticity worked and we have that carryover effect. We saw a 22% increase in walking speed, 0.14 meters per second, which is good. Like that was on par with many, if not, there's not been really any in this chronic stroke. This was 8 years post-stroke population that has had that kind of outcome, which really was compelling. Improvement in stride length and cadence. The one thing that we're the most excited about is if you walk at 0.8 meters per second or below, you're called a limited community ambulator. You're termed that. And one of the reasons is that I've learned is a lot of it, like if you're in a city and you're like crossing the street and they have the little like hand guy and the guy that's walking or whatever, that's usually tuned for right around 0.8 to 1 meters per second. So if you walk slower than that, you might get stuck in the middle of the street. And so what happens is people don't leave their block, or there's all these other things, like you fall a lot, et cetera. We saw in this 5 weeks, over 50% of the cohort go from limited community to community ambulators, which was really, really exciting to see. And it didn't stop. So this was each session. We looked at a session by session sort of average. It just kept going up. So like more in theory would get potentially higher. Like we need to prove it before we would say that. Versus the control group, they were continuing to go up, which was good, but it's just not the same slope. And so that was compelling. And then finally, I mean, as I was talking about before, we spent, if you're ever building a product, so anyone out there that ever wants to build a product, most of them fail because people can't use it or don't want to use it, not because the therapy doesn't work, right? Particularly the ones at home. And we spent as much time thinking about how to design it, how to set it up, how to make sure the sensors were synced, how to make sure it was easy to use. We learned by going to people's that have had strokes homes and watching them operate that, you often lose your ability to use one of your hands also. So something as simple as like plugging in your phone, like it's hard to do if you can't use one hand. And so like we were going to ship a bunch of stuff to plug in, and that was going to be a problem. So there's these really interesting magnetic chargers that you just sort of can set something down by, and you get it nearby, and it auto clicks in place. That was a solution we put together. And so with that, we did this outside test that 93% of users could do all the tasks that were required for it on their own, in their homes, without anything other than the instruction manual or a video. Though what we have noticed now that the product's been live, people aren't confident that they can do it. Like if they're put in a room in a study and said like, yes, they can figure it out. But oftentimes you get a new product, you've had a stroke, it's overwhelming, and you're saying, I don't know. And so like we have to call and like encourage them to open the box sometimes because of that. And if they do 2 sessions, we see they do almost 20 most of the time, but it's getting them to do the first 2 is really, really hard to do. Moviv, which means move to live, is for Parkinson's disease, just became live like a couple months ago, a month or 2 ago. And it's a similar setup. The algorithm is different. And Parkinson's disease, as we were talking about earlier, with the rehab group down here, like there's a lot of research on how rhythm can help in a similar way with Parkinson's disease. It's the fastest growing neuro disease in the world right now. It may take over Alzheimer's disease, is what someone was like. It's like the curves are like it's pretty wild, and so we're excited to help with that solution. And we have a whole host of other things that we are thinking about bringing to market into the future. We also believe that, and I'm trying to get to questions here. So we also believe that we now have all this data. We now can, we created an algorithm for chronic stroke. We created an algorithm for Parkinson's disease. But within that, there's probably like hundreds or thousands of different subtypes that you could imagine building something specific to them with all the data that we now have. We can, we've started to work around with like how do you use AI to solve that problem, right now, which is really interesting. FDA and AI don't always go together. So like that's been a little more difficult. And so we're excited about that. Music can't just help people with neuro conditions just in movement. There's a lot of research in both in helping with language. I know SLPs and others do melodic intonation therapy and other things for helping recover speech. They help with cognition. And so at MEDRhythms, like we believe that like we got to do it really well with where we're doing it now. Our next phase is now that we have the Medicare code, is to really scale up access to it on the sales and marketing side. We get that done really well. We'll both bring other walking products out, but we'll imagine what else can be helped with these patients. And so it's been a great journey so far, much to go, and we've got a great team on board. This is an old photo of our team. We've partnered with a lot of great institutions and many more people to help. So appreciate you all listening. I would love to take as many questions as you have until we hit 8 o'clock.
If you have a question, let me know and I'll come bring the microphone to you.
Got one in the back.
First of all, this is amazing that you've found a way to take music and help people regain their mobility. So
Thank you.
amazing. I have a question about, I was thinking it was just for stroke victims and not necessarily for people who have debilitating illness, but then you just mentioned something for Parkinson's. Is that available now, or is that still being produced?
Yeah, so the Parkinson's disease product is it's called Moviv, and it's live now. So it's out on the market. It has to be ordered or prescribed. Oh, all the products are meant to be ordered or prescribed by a clinician. So making sure it's kind of fits in healthcare, and then we'll bill insurance for them. So, and then you didn't really ask this question, but stroke is a recovery, right? You have a stroke, and like then you try to get someone back to another place in time, like where they can get better. And Parkinson's disease, obviously it's sort of like it's degenerative, so it gets it kind of gets worse over time. Like we're not a cure for Parkinson's disease, but it will help you maintain mobility longer is the theory, right? Like while you're on that journey.
Thing on. I have a question.
Yeah.
You said Parkinson's disease, strokes, and something else. I was wondering if you were also developing things for other diseases. Like last year, I had Guillain-Barré, and I
Yeah.
struggle with walking. So I was wondering, like other people who also struggle with that, if your technology would help them too.
Yeah, it's a good question. Hopefully the baseball season is going well, by the way. Yeah, so if someone, this is not the way rhythm works is not disease specific. It's like sort of a neurological input to the brain. And we see like in the clinic, Brian's has seen results across a wide range of reasons why someone has walking deficits because of a neuro issue. And so there's a reason to believe that it could work in other conditions that are, if you have like a Guillain-Barré, that you have a neurological condition that causes that. We now have trials underway and we've done an FND, functional neurological disorder, and have seen like really good results there. We've done NMOSD. We're working with a pharmaceutical company on a partnership there where we're doing like a 20-person trial to see if there's outcomes there. And like, as we see like opportunities, we'll study it in other conditions. We're a sort of our MO is first move is always to study it in whatever the condition it is we want to make sure it works. And so it could work in other ones. We would have to have a reason to move there. So stroke is first, Parkinson's was second, probably MS will be third. And then FND and NMOSD, we have data on also at this point. Yeah.
So you mentioned the sensors measure different data points.
Yeah.
Do they get recorded and analyzed?
Yeah. So there's actually two ways they come in. We have real-time data that's coming in that we are sort of making decisions on with the algorithm. And so there's a lot of data points that come in there. And it's an accelerometer, gyroscope, magnetometer combo is what it is. And then we also afterwards take that data and process a report of more data points, like 40 or 50 more that aren't captured in real time. All of that gets sort of in a database under that session, stored to be used for whatever future purposes that we have.
Does the patient or the therapist have access?
So the patient, we're giving them sort of some of the baseline, like how many steps did you take? How long did you walk? Like what was your cadence? Like some of that, when we did our research with the patients, any more than that, they didn't know what to do with it, right? It was sort of like, okay, translate this for me. What is this? I mean, there's always the like 2 or 3% that are like, I want it all. But the most people were there. On the therapist side, currently we're not sending it to them, mostly because doing something new in healthcare is really hard. So we wanted to fit into, like, we're durable medical equipment, so it's like ordered, shipped to home. Like, I don't want to change anyone's workflow because of that. There's a future where we're actually doing some research now and saying, like, can we send a report back to the PT or the clinician? There's actually some new remote therapeutic monitoring codes that they could bill for that. And then they can provide better oversight and care for their patients. As we've kind of grown, we've got more narrow in what we do, if that makes sense, because we need to execute really well. But it's a good question.
Because I'm thinking about the quality of the gait and quality of the posture, because one of the purposes of rehabilitation is not, well, speed is great, but also you want less maladaptive,
Yeah,
compensation
yeah,
when it comes to, so I would think that the individualized data
yeah.
collection and analysis with help of the therapist would be very helpful in terms of improving the quality of the patient's gait in terms of rehabilitation.
Yeah, no, it makes sense. And we do also agree that things like stride length and symmetry and other things are important, and saw some good. We were not powered to get the endpoint on the stride length, though we saw good directional data on that and symmetry in the pivotal trial. But it's a good point. It's really hard, though, to think about how do you send data back to a clinician that doesn't work with us, for us, right? And make it so they want to look at it. Most of the time, we've heard, don't send me the data because then I actually have to look at it and do something with it. I don't know what to do with it. And so it's a problem to be solved, but it makes sense.
I've been keeping an eye on the chat. So we've
Oh,
got a
nice.
couple of educators over Zoom. And so first, I'll just mention comment someone had made. This is super interesting. I'm an education major, and after watching this presentation, I think that utilizing music could definitely influence student focus. And then a question from an educator is, as a music teacher, I am curious, would there be a way to incorporate this into a classroom setting to aid students with both their mobility and dexterity challenges?
Way to incorporate it into the classroom for students for mobility and dexterity. I mean, you know, I would recommend, there's a academy called the Neurologic Music Therapy Academy, which actually trains people to do a bunch of these interventions. I think the first step would be to go there and to look at sort of like some of the resources on how they think about a therapist doing the interventions. Not that they would be doing therapy in the classroom, but that would be really good guidance on how to think about doing it yourself.
Excellent, thank you. Quick question from somebody else in the chat. What is the cost per unit for a MedRhythms device, and are they covered by insurance?
Yeah, so insurance is covering it about 50% of the time right now, but we are still fighting a bunch of the ones that are denied. The VA covers it all the time, though. So the VA is actually for healthcare technologies is the most likely to adopt something early and fast out there. And so that was the first place we went. And the cost, it varies pretty widely because of negotiation with insurance and where it goes. And so hard to pin down like an out-of-pocket cost. I think the starting point for insurance is $1,100 a month, but we never see $1,100. It's sort of like where the starting point is.
And then last question that I've got in the chat for you is, have there been any flaws mentioned by those who have used it?
Well, so challenges, right? So challenges, one is like to get them to start to use it in the first place that we found. Two is, and we've updated some of our labeling on this. If you actually walk way too slow and almost to the point where like you're mostly wheelchair bound, which we knew this, but the people that can walk maybe 10 meters or 20 meters, if they get an order for the device, it actually has a hard time calibrating. And so we've had that being a challenge that we've had to warn people about. Other than that, we measured adverse events in our trial. You're asking people to walk. So obviously like the downside is like maybe they fall more, right? These sort of things. We saw versus the control group, we had something like 2 falls, like not during a session, but just outside in their daily lives, and the control group had 6. And so that was, it's not a claim, but it was directionally good. Those questions here.
Over the years, I've done a lot of equine therapy.
Yeah.
And one of the things I watched was the outcome of somebody who had cerebral palsy or
Yeah.
somebody who had had
Yeah.
a stroke.
Yeah.
Curiously to me, and it didn't click together until
Yeah.
tonight, the gentleman who was a Vietnam vet and who had significant limb loss and
Yeah.
trouble with his equilibrium wore headphones, and he would tie the music to the gait of the horse.
Oh, interesting.
And what was interesting to me was when he would get off the horse, his gait was so much better because of the gait of the horse and the music. And he used to say the music made all the difference.
Wow. That's a great story. I've never thought about that combo before, but that's That's really interesting. Yeah.
I was just curious about any thoughts to expand this to like pediatrics, kids with cerebral palsy, that type of thing?
Yeah. So we always start back with like what Brian did in the clinic. Like he had treated some pediatric, some cerebral palsy in other patients and seen some really good results there. I think it's always been in like the big vision. And then it's, where do we invest for the trials and other things like that? So it's definitely a good idea. I would say not in the next couple of years is where we won't focus there. Also, like product design for that it'd be fun to, like, actually, I think it'd be really fun to do. Yeah, different music, different design, different setup, right? Like it would be really fun to do, but the design of a stroke one and a Parkinson's was similar-ish, right? So we didn't have to redo everything. I think we'd want to almost go back to the lab and redo even the look and the feel of all of it for that one. So not yet, but hopefully sometime.
So you might have mentioned this through the presentation, but so like if we had a relative who had a stroke,
Yeah.
was in the hospital, obviously they took care of them. You had mentioned the product doesn't really come from the therapists that are there. So how are the connections being for like our relatives, our loved ones, making the connection to get this product if it's not really being used in the clinical setting per se?
It's a good question. So it needs to be ordered or prescribed by like a doctor or a therapist, depending on the state. For us, there's a couple ways to do it. Like you can go to our website in TandemRx and sign up that you're interested and set up like a consult with someone on this team called Neuroscience, and that they can actually go get the prescription or order from your doctor. You can also download the form and take it to your doctor or your loved one's doctor and do it that way. But if you come to the website and you did a consult and we thought it would be relevant, like we could take it from there if there was an interest. And I think that would probably be the smoothest way until it's sort of like we are working with some areas and some rehab clinics. Like we have a small team, so we don't have a full sales force out there to make them aware of it, get them a demo kit in the clinic, kind of get it in the workflow. We don't have that everywhere yet. So like if it's in mind for you, I would go to the website and kind of work through that process.
And so where you are based out of Maine now, the hospitals in Maine are pretty familiar with the product now? Or?
No.
No.
No. There's a no down here. Yeah. Yeah. Excellent. Yeah, well, we should talk about that. Yeah. Not yet.
Right, not yet, but that's what we're going to work on. Any other questions? Have you tried the product with somebody with hearing loss, someone who depends on hearing aids? Does the earpieces overcome the hearing loss or?
Well, so it's a good question. So you need to be able to hear it, right? There's a few ways to work around that. One is the headphones, as part of the design, actually wrap around the outside of the ear. They don't go in the canal. So they're bone conduction. We actually found people love those in product, because they'd be like, well, if I'm out about, I can still hear my surroundings while I'm hearing so they work actually really well with most hearing aids. The headphones do. There's an ability, if they're hearing aids with Bluetooth, to connect the Bluetooth directly to the hearing aids. That's another option. And if not, then like we'd have to evaluate, right? Like if you need to be able to hear to get the benefit of it, but there's ways that we've tried to find around it.
And the person I'm thinking of also has not had a stroke or anything like that, but speaking of equilibrium, developed a balance problem. If he's moving, his gait's not great, but if he's moving, he's had no problems whatsoever. It's when he stops. He has to have a cane so he doesn't fall over.
Oh, wow.
So I don't know if anything like that would help with maybe improving the gait. Would that help with equilibrium? Talk to the therapist in the front of the room.
Yeah. I'm going to defer that one. Yeah.
Heather will help you.
Yeah.
Any other questions? Well, thank you so much for being here. I'm sure people will want to come up and chat with you, and we will claim you from being from a Rooster.
Thank you. I've been waiting for that. That's why I came. Yeah.
Thanks, everyone. If you have a question for him, I'm sure he'll be here for a few more minutes to. And thank you all you students for coming. We appreciate that.